So I got finished doing the test review problems, and then I was like, hey, why don't I do some more review, looking back at like old class problems and stuff, making sure we know what we need to know for the exam. So I went back to the class problem, shoot, I went all the way back to the first. No, not the first. Excuse me. No, I went to the last set of class problems, and just looking through the problems and the solutions. Let's take, for instance, this first table. Everything's pretty straightforward. You go, you look it up, except for this x. That's the quality, and I know I'd forgotten what it was, so allow me to do a little tutorial on that, and I'll probably keep doing this with other stuff as I find going through the problems. Alright, the x is the quality. So let's go ahead and define it. Quality is x. Okay, now what does this mean? Like, what is the significance of quality? Quality is basically talking about the proportion of the mixture that is under the steam dome. You know, under the steam dome, we've got liquid over here, we've got vapor over here. It's talking about how much vapor do we have versus how much liquid do we have. If you're over on this side, of course, there's going to be more liquid and less vapor. And then if you're on this side, there's going to be more vapor and less liquid, until eventually you cross over into the vapor only area. Alright, so the quality basically defines, like, where are you proportionally within this dome. I imagine if you were to draw a line of the quality at all the various pressures and temperatures or whatever, let's say this is a PV diagram. If you were to draw the corresponding qualities at just a whole bunch of different temperatures under the steam dome, I imagine it would look something like this, because it's a proportion. It's not like a constant value. Okay? So it looks something like that. Anyways, but what is it exactly? Alright, the mathematical definition is x equals h minus, excuse me, I am looking at the wrong thing. Hold on a second. Let's look at the solution. Here we see, right here, yeah, it's h minus hf divided by hg minus hf. Let's get, yeah, minus hf over hf minus hg. Now let's look at this in terms of an image. Alright, so here's our steam dome. We have some property, we have some mixture that is, say, over here. Okay, what does this mean mathematically? Where's our, we're going to keep this as a PV diagram. So we got the pressure decreasing until it becomes a saturated liquid, and then going constant until it becomes a superheated vapor, and then it's going down again. Alright, so this is our given T, whatever that may be. And we also have this known specific volume. Okay? Now we want to talk about, like, what is the quality at this point? Well, if you look at this mathematically, H is going to be the actual enthalpy, which I don't know how accurate this is, but I like to think of H as being proportional to V. So as V increases, as the specific volume increases, the enthalpy increases. I think that's generally true. That seems to be the case. Alright, so you're looking at the heat of this given point minus the heat of fusion, which is the amount of heat it takes just to get it to saturation at this given temperature, or at this given pressure, whatever you want to call it. But the heat of fusion is the heat it takes to get from a compressed liquid to a saturated liquid. So H minus HFG is actually going to be this region here. So this is H minus HF. Alright, now what's HF minus HG? Well, we have our HF already marked out here, minus the HG. The HG is going to be the heat required to turn it into a gas, the heat required to make it into a superheated vapor. So, let's extend this line down. This right here is going to be HF minus HG, which is to say that it's the heat that it takes to go from a saturated liquid to a saturated vapor. Alright, this is actually also given, this enthalpy is given as HFG in your property tables book. You'll notice that the three columns are HF, HFG, and HG, and HFG is always equal to HG minus, it's just basically the difference between these two, how much space, how much enthalpy is in between those two. Okay, so the quality is basically telling you how far along this line it is in a percentage, because you want to multiply it by 100% so that you get an a fraction sort of thing that you can deal with. So let's say your quality is 2, or when you're looking at percentages, your x is always going to be greater than 0, and it's going to be greater or less than or equal to 100%. This is because it's percentage. You can't have twice as much as you actually have. You can't have negative amounts of this. It's an actual mass. Excuse me, not an actual mass, but an actual absolute measurement, which is the enthalpy. And it does correspond to the specific volume as well. You notice how I said they're proportional. So this proportion also tells you something about the specific volume. If the quality is very high, then you know that you're going to have lots and lots of gas, because if the specific volume is high, you're going to be way over here in going into the region where there is much more vapor. But if your x is low, then you're going to be going to a small. You're going to be going over only a small bit, and you'll still be in the largely liquid region. I'm sure there's a mathematical exact correlation. Yeah. Let's take a look at this. Okay, there's nothing that talks about the specific volume or mass in here, but there is definitely a certain correlation there. Alright, hopefully this is all you need to know about quality. If you take a look at this, then you can tell that you can use this number to find your H's if you already have one of them. Let's say you have HG, and you want to find HF. Alright, you can just do some little rearranging. X times HF minus HG equals H minus HF, and then just solve for HF. That's minus, not times. So let's see, HF times X plus 1 equals H plus X HG. So your enthalpy of fusion is going to be equivalent to X plus 1 over this X is corresponding to a specific enthalpy. It can be anywhere inside of this range, and that's fine. Because like I said, this is going to be between 0 and 100%. If it's 0, then your given enthalpy is